Okay, dear students, welcome to 10-minute series. Uh, Next definition we will study regarding storage coefficient. So this term is usually seen in confined aquifer. So whenever we are studying groundwater engineering, so storage coefficient basically it is defined as the volume of water that an confined aquifer, you can underline this, confined aquifer releases per unit surface area of aquifer per unit change in the component of head. Normal means perpendicular, normal to that surface. Okay, so this is the definition. We will understand. See, storage coefficient, whenever we are having some confined aquifer, see, suppose this is your ground level. Okay, so this is your confined aquifer. Okay, you can see, so it is one type of pressurized flow. So storage coefficient, it is defined as volume of water that an confined aquifer releases. Okay, suppose we are digging some well, so volume of water it will release per unit surface area of aquifer per unit change in the component of head normal to that surface. Okay, so the basically it is talking about the drawdown. Okay, so how much volume of water the confined aquifer can release, that is related to the definition of storage coefficient. And another coefficient, that is coefficient of transmissibility. This is also very important, coefficient of transmissibility. Now see what is the difference here. Here we will be taking a column. Okay, suppose you can see in 3 dimension. Suppose this is 3-dimensional column. Okay, so it is a rate of flow of water through vertical strip. This is your vertical strip. And its width is 1 meter. Okay, so this strip and its length will be extending up to full saturation height. Okay, so let us write definition. Coefficient of transmissibility it is denoted by T. Okay, so coefficient of transmissibility, it is defined as the rate of flow of water through a vertical strip of aquifer of unit width means 1 meter and extending the full saturation height. Under unit hydraulic gradient. Okay, so basically here the formula is T is equal to Bk. Okay, so K is permeability, B is the width, and transmissibility is defined as T is equal to Bk. So we have seen coefficient of transmissibility, we have seen storage coefficient. Okay, earlier we saw coefficient of permeability. Okay, now we will move towards one concept related to geotechnical engineering, that is coefficient of consolidation. See, these things are given in your books, but the most frequently asked questions are covered in this 10-minute series. And I will be explaining you all the important formulas. Okay, so just you can note down all these things. So coefficient of consolidation denoted by CV. Now see, what is the unit of CV? Basically consolidation consists of two things. One is compaction and another thing is permeability. Okay, because the water needs to be drained out. So compaction, it is how much distance it is compacted, so it is in centimeter, and the unit of permeability, suppose it is in centimeter per second. Okay, so if I combine both these concepts, so consolidation will have, CV will have unit, it will have unit centimeter square per second. Got it? So this is the unit. So basically it is a combination of two concepts, compaction and permeability, which gives rise to consolidation. Okay, so first of all remember these units. Now the formula is CV is equal to K upon mv gamma w. So mv is coefficient of volume change. Basically you can write it directly, is equal to K1 plus E0 AV gamma W. And from this formula we can also find out the settlement. SC is equal to MV HO delta P. So what is MV? MV is coefficient of volume change. HO is your initial height, and delta P is change in delta P. I am writing on another page. Delta P is change in pressure. So here remember one simple formula which will be very useful in MCQs, frequently asked. Delta V by V0 means initial volume, change in volume upon original volume. Delta V upon V0 is change in volume upon original volume, is equal to delta H. Delta H is change in thickness or change in height. Okay, change in height of the soil sample or soil upon original H is equal to delta E upon 1 plus E0. Okay, so this is one of the basic formula. Delta V, I am writing delta V is your change in volume, and V0 is original volume. Okay, delta E is change in void ratio, and E0 is original void ratio. We know void ratio basically E is VV upon Vs, volume of void upon volume of solid. See, whenever this sample, this is suppose soil sample, so it will be having some voids also, okay, and this is your height. So initial height will be suppose h0. After this load, the height will be some another value, it will be suppose h, okay. So change is what will be delta h? Delta h is basically h0 minus h. So this is the change, okay. So this is delta h, okay. Thank you very much.